So, welcome everyone to the next edition of the Unheated Podcast. I'm Priya Shah of Theya Ventures. We're an early stage a climate investment fund based in India. And I'm delighted here to have Mikael from Ocean Harvesting here with us today to discuss his venture and the exciting things that he's been doing. So, thank you so much, Mikael, for joining us today.
Thank you very much for inviting me. I'm excited.
It's a pleasure. It's a pleasure. So what we decided to do, I think, is to kind of run through a similar conversation that we do with our at our other podcasts, and maybe give a brief introduction to the company, followed by Mikael's background as well. So Ocean Harvesting Technologies is a Swedish company that develops a novel technology to transform ocean waves into clean, reliable, and cost-efficient electric energy. The company was founded in 2017, and its proprietary technology offers high annual energy production with breakthrough power takeoff and advanced force control, making it possible to maximize the energy output from every individual wave. And a bit about Mikael. So Mikael has 10 years experience in wave power development, technology and system development, software development and simulations, project management, and IP management. And Mikael holds a bachelor's degree in electrical engineering and computer engineering from the Blekinge Institute of Technology in Sweden. So really excited to have you here today, Mikael, and thanks a lot in advance for sharing your thoughts on this very important topic and how you started the company. So I think that's probably what we will start with, to begin our conversation is, what was the sort of motivation to start ocean harvesting? And can you tell us about how and why you chose wave energy as a way to address some of the issues posed by climate change?
Yeah, thank you. So we actually started already in 2007, and it was after I read about wave power for the first time, and it just caught my interest, and it started a process that I couldn't stop thinking about wave power and how to make a wave energy device to convert these powerful motions of the wave into electricity. So it was a calling for me to start developing this technology. And then to bring up to date 2017, we developed a few different concepts during the first 10 years of the company. And after these 10 years, or during these 10 years, we learned a lot about what is required by a wave energy converter to become efficient and how to extract a lot of energy from the waves. So this started from a clean table, the development of the InfinityWEC wave energy converter, which is the technology that we are developing today, which has been designed to achieve a high performance with a power takeoff solution that can adapt the control the force and control the phase of motion of the buoy to match with the waves. This is essential to achieve high power capture. So this was the start of InfinityWEC, and then the design has been refined up to the 6th generation now, where it has been greatly simplified. We have increased the capacity, and we are also developing a buoy which is made of high performance concrete. So the driver for this technology has been to improve the resource efficiency, how to use as little amount of material as possible for the amount of energy the device can produce.
Wonderful. Thank you so much for that very comprehensive overview of the business. And my next question was, why choose wave energy? Just curious, how does it sort of differ from solar and wind, and how does it address challenges like intermittency and storage compared to other renewable energy?
Yeah, for me, as I mentioned, this came out of an interest, just how to build a machine for wave energy. So I've always been focused on wave energy, but during the years we have learned and compared to solar and wind energies. And I can say that one very good aspect of wave energy is that it complements the other resources in a good way, because wave energy produces electricity at different times than wind and solar. So it can help to stabilize the grids and reduce the need for energy storage to balance electricity production and demand. So also for wave energy, this is quite important. It is less mature than the other sources, but it provides an added value by the capability to produce electricity when other sources do not. So this means that the electricity from wave energy can be sold at a higher price on the electrical market.
Yeah, that's a very interesting, thought process actually, because then there's another advantage, which is obviously that it's readily available. I mean, I understand that solar and wind is, but I think with most locations that you're looking at, it's very easy to get access to the supply. Is that right? Or how do you actually find the locations to tap into?
Yeah, with our technology, we need a certain depth. The power takeoff has a function that we call hydrostatic pretension. Half of the control force that is provided to extract energy comes from a spring function, and we use the pressure from the water around the power takeoff to provide this spring force. So this puts us at around 80 meters depth, down to 200 meters depth, and for this reason we target the same areas as floating wind power, which is also quite interesting, because if you look at combining wind power with wave power, they do actually not compete for the same resource. Waves are accumulated energy across large areas where the waves are brought up by the wind blowing across the surface. So a wind farm extracts energy directly from the wind, and waves are accumulated wind energy from other areas. And this also has advantages that you can increase the production capacity of a certain area. Maybe we can access into already existing wind farms where all the permits and everything is already done. I also want to mention one other thing with wave power. When you compare to wind power, that is interesting. We have done a case study for an oil and gas company. It was in the North Sea, and we studied the production profile of electricity produced from a wave farm of 100 megawatt compared to the wind profile, and found that we actually need a lot less energy storage to balance the electricity produced from the wave farm compared to the wind farm. So we had 50% less round trip to the energy storage, and we needed 30% less capacity in both energy storage volume and the power capacity of the storage, just to mention an advantage with wave power. But I still believe that combining the sources is the best approach to improve the stability of the electrical grid, and this will be an increasing challenge during the transition to renewable energy.
Yeah, very interesting. And just to that point, have you found good wind developers to partner with in this journey? How have you kind of executed some of these projects, and who are your clients? Are they the same as the wind farms or slightly different?
No, so far we are still early in our development. We are at technology readiness level 5. So our main focus now is to develop the technology. We have focused a lot on raising the performance readiness level. So we have not engaged in collaboration with end customers yet, and also not wind power companies. We have had collaboration with an oil and gas company when we did the case study, but this is something we need to work a little bit more on to secure industrial involvement in now the next phase of our development, which is to verify the technology in the scale 1 to 3. So we are now taking the technology forward in joint industry projects and looking to engage further in these industrial collaborations along with that. I think it will be very important for the commercialization to establish strong collaborations with existing industries.
Understood. Understood. Thank you for that answer to that question. So, my next question is really about government support for wave energy and wave energy production. So, historically, there's been a lot of subsidies on solar and wind and those more well-known forms of renewable energy. But how about for wave energy? Is this something that you're working actively in Sweden with the government, or are there other players that are lobbying? And how does it work in that respect?
Yeah, I think there is very good public support. In Sweden, the Swedish Energy Agency, for example, have supported several of our projects, and both of the ongoing in the joint industry projects that we are now involved in is part funded by the Swedish Energy Agency. So, and on an European level, there are several programs under the Horizon Europe that it has a focus area involving wave energy. So I think the key here is to establish collaborations, consortiums with other companies and research institutes and academia to form good projects which can forward both your own specific technology, but also come to a more generic use for others in the sector as well, to move the sector forward. And also to stimulate collaboration between developers, because this I think is a challenge for the sector, the high diversity that we see.
Yeah, absolutely. And to that point, I mean, do you see a lot of challenges in commercialization? So essentially, what would be the time frame, for wave energy players like yourselves to basically reach the same level of, customers, go to market, pricing, basically the benchmarks that currently wind and solar are, basically leading ahead with?
Yeah, I think wave energy is still an emerging sector. There are some front-running companies that are close to the market now, but there is no large-scale wave farms producing power in operation today. So we are very far behind, I would say, wind and solar. And this is, of course, a difficult threshold for wave power to enter into commercial space, because a new technology, when you make the first units, will of course be quite expensive relative to established technologies that has been rolling out in terawatts of power. But if you look at in the long run, I started my introduction by mentioning, for example, resource efficiency, which looks at the amount of materials and the types of materials used per megawatt installed capacity or megawatt hour produced annual energy production. If you look at different resources or specific resources, but we have made some comparisons on the cost associated with the used materials and the CO2 footprints used for the materials, and it looks really promising. If you pick one floating wind power projects, it was a few years ago now, so the numbers may have improved, but Highway Scotland had a structure entirely made of steel with some ballast. And if you compare the specs of InfinityWEC, the material cost, if you disregard everything else, just look at the cost of material in terms of a price per ton and use the same price per ton for both technologies, we end up with 6 times lower material cost and 6 times lower CO2 footprint from the used materials, because we have, first of all, half of the amount of material, and we have replaced a lot of the steel for concrete, which is a material 20 times less expensive than steel and easier to manufacture. So what I try to say with this is that I think wave power, once it is commercial, and has reached the same level of deployment as wind power is now, will be much lower in levelized cost of energy. But it is a race to get there, and we need to pass the threshold of commercialization.
No, that's a very fair point. And I was curious to understand if there are any further players doing this apart from yourselves. Maybe you could give us a bit of an understanding of the competitive landscape, or even on the public-private partnership side globally, who are some of the leading players who are also working on a similar technology?
Yeah, there are several device developers for in wave energy. To name one, we have Core Power Ocean in Stockholm. It's also a Swedish developer, which is further ahead than we are. They are now deploying a small demonstration array in Portugal. We also have Carnegie Clean Energy from Australia, with some a lot of business also in Europe, involved in the Wave Energy Europe program that we also have a collaboration with through one of our joint industry programs, which is about developing efficient concrete structure for the prime mover, the buoy of the wave energy converter. So this is to name a few. We have also, I think there is. I can sit and mention many different developers that work on different types of wave energy converters. I can mention that the technologies I mentioned now, Carnegie Clean Energy and Core Power, they are also developing point absorber technology, same as we are with InfinityWEC, and they also have a focus on phase control techniques, but they implement this in very different ways. So it's very interesting to compare what we are doing and to establish collaborations to try and help each other.
Yes, absolutely, absolutely. Couldn't agree more. And curious to understand as well, given that there are some high capital costs and long development timelines, how does the wave energy industry attract investors who traditionally focus on shorter return cycles, for example, like solar and wind? How do you kind of balance that expectation that investors have for returns?
I think this is actually very difficult, and currently, I think there has been some advantage. As I mentioned, Core Power Ocean. This is a company that just raised quite a lot of money, but otherwise it is difficult for most developers to raise private equity, including for us. It has been difficult to raise private equity except for the exact same reasons that you mentioned. The timelines are long. And I think investors are quite used to short cycles with less risk in their investments. And right now there is a climate that is quite risk sensitive, that is prohibitive. I can see several of other WEC developers are turning to crowdfunding schemes to try and raise the private capital, which is can be successful, but it can also be difficult when you want to raise VC money, maybe at a later stage. So this is not easy, and I think one reason behind is that wave power is not a new thing. It has been developed for a long time. There are patents over 100 years old in this space, and there has been some massive failures where technology have simply not proven to be affordable or broken in storms that has brought down confidence. We have seen power utilities being much more involved, and also OEM companies in the past, but they are quite not so active at the moment. Maybe they are coming back. I think we need to build up the confidence in reliability of these devices, and we need to improve the affordability. There is a trend to focus more on the power takeoffs and implementing these advanced control strategies that we are also following. to really improve the affordability. I think on the material side is also very important because these devices are large. You need to think about how to make cost-effective structures, especially for the prime movers. And this is also in line with our work to replace steel for a much lower cost concrete.
Absolutely. And no, we wish you all the best of luck. I think with this, we'll conclude the conversation for today. So thank you so much, Mikael, for your time and for your really valuable insights and perspectives on wave energy, on the solution and the exciting technology that you've built in a very path-breaking way. And we look forward to following you on the journey and keeping in touch on what you're building. And we'll, as our listeners, as you know, are mainly based in India, mainly founders that are building exciting technologies like yours, we'll be sure to ask them to reach out if they have any questions or thoughts about building in this space. But thank you again. See you soon. Thank you.